So good day everyone. So I will continue our reports. But today I'll be talking about the properties of variance and standard deviation. So number 1 is the most commonly used measures of variation, most especially in research. Number 2 is shows variation of the individual scores about the mean. So first, variance and standard deviation are the most commonly used tools in research to measure how spread out or varied a set of data is. So of course, they help us understand how much the individual scores differ from the mean. So if the scores are close to the mean, the variance and standard deviation are small. If the scores are spread out, the values are larger. Next, interpretation of standard deviation. If the value of standard deviation is large and the average, the scores in the distribution will be far from the mean. Therefore, the scores are spread out around the mean value. The distribution is also known as heterogeneous. So, as I said earlier, if the scores are close to the mean, the variance and standard deviation are small. And if the scores are spread out, the values are larger. So next, measures of variation. So coefficients of variation shows variation relative to the mean. It is used to compare two or more groups of distributions of scores, usually expressed in the percentage. The smaller, the larger of the value. The smaller the value of the coefficients of variation, the more homogeneous the scores is that particular group. On the other hand, the higher the value of the coefficient of variation, the more dispersed the scores in that particular distribution. So now, when we want to compare the variation between two or more groups, especially if their means are different, we use the coefficient of variation. This is a relative measure of variation. It shows how much the variation exists in relation to the average, which is the mean of the data. So it's usually expressed as the percentage. The lower coefficients of variation means the group is more consistent or homogeneous, while the higher percentage means the scores are more spread out or dispersed. In summary, variance and standard deviation help us measure how much scores vary, and the coefficient of variation help us compare that variation between different groups even if their averages are different. As you can see, the formula in computing the coefficient of variation is CV is equals to S over X 100%, where X is the mean value, the S is standard deviation. So here is the example. Find the coefficient of variation of the given data below. So the analysis here is the scores in section A are less scattered than the scores in section B. In section C, in other words, scores in section A are more homogeneous than the scores in section B and section C. Another way to interpret this is the scores in section C are more spread out than the scores in section A and section B, or the scores in section C are more heterogeneous than the scores in section A and section B. So next, describing relationships, correlation. So another statistical method used in analyzing test results in the correlation is the tool that we are going to utilize if we want to determine the relationship or association between the scores of students in two different subjects. Is there a relation between the mathematics scores and the science scores of 15 students? What type of linear relation exists between the two sets of scores? Such questions can be answered using the concept of correlation. In this chapter, the different types of computing the correlation coefficient when raw scores and ordinary level of measurement are given. The graphical method of scattergram of determining the relation between two groups of scores are also discussed in this section, but only limited to linear relation. relationship. So here, correlation help us determine the relationship of association between two sets of scores. So this is where the correlation comes in. It tells us whether the relation is positive, negative, or if there's no relationship at all. A positive correlation means that as a score in one subject increases, the score in the other tends to increase too. A negative correlation means the opposite. When one score goes up, the other goes down. So correlation refers to the extent to which the distributions are linearly related or associated between the two variables. The extent of correlation is indicated numerically, called by the coefficients of relationship. The correlation coefficient, also known as person product moment correlation coefficient, in honor to Carl Person who developed the said formula. The correlation coefficient ranges from -1 to +1. So in this topic, we'll also learn different ways to compute the correlation coefficient. So depending on whether we're using row scores or ordinal level data, the correlation coefficient is a number between -1 and +1 that shows the strength and direction of the relation. So we'll also look at the graphical method called the scattergram or scatter plot, which shows the relation visually. Just keep in mind we're focusing only on linear relationships, those that form a straight line pattern. So overall, correlation is a powerful tool to see how two sets of scores move together and to describe the strength and direction of their relationship. So there are three kinds of correlation based from the correlation coefficient. The number one is positive correlation, the second one is negative correlation, and the third one is zero correlation. So there are two ways of identifying the correlation between the two variables. Number one is using the formula, and the number two is using the scatter point diagram, as I said earlier. So let's move to kinds of correlation. So the number one is positive correlation. So high scores in distribution X are associated with high scores in distribution Y. Our low scores in distribution X are associated with low scores in distribution Y. So this means that the value of X increases, the value of Y increases too as the value of X decreases. The Y values will also decrease. The line that best fitted to the given points upward to right, as shown in the scattergram of positive correlations. The slope of the line is positive. So a positive correlation means that as a one variable increases, the other also increases. Likewise, when one decreases, the other decreases too. So for example, if a students who score high in math also tend to score high in science, that's a positive correlation. So the pattern of the data points in a scattergram goes upward to the right. So the line that best fits these points has a positive slope. It means both sets of scores are moving in the same direction. So high goes high and low goes low. So the second one is negative correlation. High scores distribution X are associated with low scores in distribution Y. Low scores in distribution X are associated with high scores in distribution Y. This means that as a value of X increased, the values of Y decreased, or when the values of X decreased, the values of Y increased. The line that best fitted to the given points downward to the right, as shown in the scattergram of negative correlations, the slope of the line is negative. So here, a negative correlation means the opposite. As one variable increases, the other decreases. So for example, If the students who score high in math tend to score low in art, and vice versa, that's a negative correlation. So in the scattergram, the points move downward to the right. The line of best fit has a negative slope. Sorry. So here the scores move in opposite directions. High goes with low and low goes with high. So the last one is zero correlation. No association between scores in distribution X and scores in distribution Y. No single line can be drawn that best fitted to all points as shown in the scattergram of zero correlation. No discernible pattern can be formed. So here, zero correlation means that there is no relation between the two sets of scores. So for example is, if students' scores in math have nothing to do with their scores in music, there's no clear pattern or trend. In the scattergram, the points are scattered randomly. You can't draw a single straight line to present the relation. That means the values in one subject do not affect the value in order. That's all. Thank you.